Hello and welcome to the fourth episode of Git on our channel CloudSewa the Cloud. In this episode, we're going to learn about the use of Git Merge and the difference between Git Merge and Git Rebase, and we're also going to learn about how does merge conflicts occur and what are the ways to mitigate it and solve the issues of getting a merge conflict. So basically, we'll start with what is Git merge. So Git merge is a way of putting a forked history back together again. So let me tell you a scenario about you're getting a branch and you are doing certain work apart from your main backbone of your master's work, and after having some changes and work and you need to put it all back together, we are either going to merge it or rebase it based on the scenarios and based on the requirements of what the project needs to be done. So let's get on and move on with the topic of Git merge. What is Git merge? It's a process that unifies the work done in two branches. Yes, it's the same thing. And so while we merge the branches to the master, we first check out and move on to the branch master, and then we merge the other branch to the master itself to signify that the other branch is going to get merged to the masters and not the other way around. Okay, so what are the pros and cons of Git merge? So Git merge is simple to use and easy to understand and maintain the original context of the source branch, preserves your commit history and keeps the history graph semantically correct. So in case of Rebase, it's basically like a linear workflow module. So in Merge, Git Merge, it's like a cyclic module, and like all the work done commits you've done in your branches gets visible in the main branches, and all the main branches commit get visible in your feature branch. That's basically on your Git merge. And if you want to omit all the unnecessary commit logs and commit history, so we can use Git Rebase. So, but why don't we use Git Rebase so often? It's because like if you're working in a project that involves working on the master on the root by various different personnels, and you make changes, other make changes, and the changes needs to be recorded. So on a public repository, or if you're working in a larger group, we always need to use Git merge. So if you are developing something on your own, you can use Rebase. It's like you don't want to like keep a long track of history of commits of what you have done. Also, we can also use it in certain bases. Let's say you're working on a branch from a master, and but you have bug in your system that's been going around for like many time ago, and somebody develops and releases the bug fix, and then, oh, that's a bug fix that I want. So you can rebase onto the bug fix, and you can take it on your branch to enhance your project. So that's one of their advantages. And like with another slides, we move on, we get to know a bit better about what Git merge is and what Git rebase is. So basically, the cons of merge is history can become intensely polluted by lots of merge commits because multiple people are working on the same branch. Yes, so it might result in unclear workflow about what people did, and it's like multiple commit messages with so densely populated will might result in non-clarity. So that's the cons of Git merge. Okay, Git Rebase. Rebasing is the process of moving or combining a sequence of commits to a new best commit. Rebasing is most useful and easily visualized in the context of a feature branching workflow. So, as I have already specified you, um, what rebasing is and where we can use it to get the most out of it. Okay, there are many potential applications to rebasing. Git is a data structure. You can do it arbitrarily complex, creative, nasty things to the underlying DAG. So DAG is basically a graph. It's a cyclic graph, direct cyclic graph. But the two usual use cases are when. So basically, when do we want to use Git Rebase the most? So somebody commits something really nice to the master branch, like a bug fix, and you'd really like to have that in your work in progress. Yep, that's one time. And you're happy with the results of your experiment and want to add it to master, but you don't want to merge since that could look messy. You like having master to be straight line without splits. So, but I have to warn you that on this master that this point is talking, it shouldn't be of a public repository. So basically keep that in mind and you'll be fine. So let's move on to another slide. So it's a figurative representation of how the nodes work while we do Git Merge and how the nodes work while we do Git Rebase. As you can see, here has been the branching, and let's say the purple or let's say the pink node is denoted as a feature branch, and this is a master node. Master node has some changes by others people done and some other changes, and during this development of feature, when we merge, the last node gets merged in the last latest node of the master. So in case of rebase, as you can see, the branching occurs and we have this version 1 of feature. Okay, version 1 of feature, version 2 of feature, version 3 of feature, and when we rebase, so basically this all the tree, it gets come along here. So we have like everything we did here, it goes on to master and it starts new, and we have in a linear way, not in a cyclic way. So basically, Git Merge is on a cyclic way, and Git Rebase is in a linear way. So we move on to the next slide. So okay, Git merging is nice because it's a non-destructive operation. The existing branches are not changed in a way. This avoids all of the potential pitfalls of rebasing. So on the other hand, this also means that the split branch will have an extraneous merge commit every time you need to incorporate upstream changes. Yes, that's basically I've explained to you earlier. If master is very active, this can pollute the split branches history quite a bit. Yep, all the commit histories is gonna come up to your splitted branch. So when it's possible to mitigate this issue with advanced git log option, it can make it hard for the developers to understand the history of the project. So we can also like minimize what log it's gonna show on the history, like commit message. So on our split branches, which we want to show and not show by using git log options, but it's still quite complex and confusing. So we have to like think smart and choose a better option while we can. So it's not about how it looks. Rebasing allows backtracking to specific commits when hunting bugs. It makes Git Bisect a very powerful tool for pinpointing buggy commits. So, as I've already told you, while developing on individual projects, you can use Gitbase. It's a very good process and it's a very good practice. So, what's the advantage of Git Rebase is that if we do have many faulty commits, we can use this git bisect command to exactly locate and pinpoint all the buggy commits, and we can like it's like quite easier to troubleshoot what the error has been, and we can like amend those errors. So when you know which small commit introduced the bug, you are able to fix it more quickly. This is also why smaller commits are way better than large commits. So basically, that's the difference between Git Merge and Git Rebase. So as you can see on the screen, you have the figurative representation of how the nodes and branches works in the procedure of Git Merge. So in the first figure, you can see when you initialize a repository, the node M1, the main node master, is created, and while we create the branch bug fix and we check out to that branch, we're currently staying on the bug fix, and that's denoted by asterisk, but it is not separated from the master node. And while we do some changes and commit to the in the bug fix node, and then it's separated in a linear way from the node M1 master to the node M2 bug fix. So in next slide, we can like see when we then move on to the master branch and using checkout, it's denoted by asterisk, and then we commit. The linear pattern gets broken down into diverging pattern. So as you can see in the figure, so from the node M0, it's separated to the node master 1 and node master 2. And when we do like multiple changes in the branch bug fix and the master, and then when we finally merge it, it's gonna be a cyclic pattern, and then we merge like this. While staying in the master, we merge the branch bug fix, and then it comes to a node M3, which is also the main master node, but it's the merge one. So here we have a figurative representation of how Git Rebase works in the case of nodes and branches. And as you can see in the initial steps, git init and git checkout -b bug fix and git commit. So it's a linear representation. It's all the same as we did on Git Merge. And so then git checkout master and git commit. So here's the branching out. So in case of git rebase bug fix, so here's the node, and we have separated from the changes M1 and M2. There has been another change in the master, so it has the name M3. And while we do git rebase bug fix on the master, and in this particular thing, the M2 node and the branch bug fix gets attached to the node of the master M3. As you can see in the figure, it's denoted by M2 dash, but the linear sequential flow is all done in the master branch. So the linear flow of the nodes is the representation of the master branch, all the works that has been done in the master branch. So for the further clarity, we have this figure to compare it with commit, merge, and rebase. So in the commits in master, so let's say we have the process A and B, and in master only A has been altered, and in feature only B has been altered. So you can see there's the representation of a bold italic on A and a bold italic on B. The commit has been made. So while doing merge, so here in master you have the changes in only A, but in the feature section the changes done in only B. So while doing a merge, you're gonna get a result of the both changes that's denoted by a bold italics of A and B. So in case of rebase, so here we have the feature A and B, and on the branch of feature there's gonna be changes on the B, and on master there has been changes on A, that's denoted by bold in italics of A, and on feature is denoted by bold in italics in B. So while doing a rebase, at first this process, the only italics of that symbol is denoted here, as you can see here. So after again another process, the final content of the both the changes that has been committed in master and feature, which is denoted by bold and italics of A and B, is obtained, and this feature branch it's get deleted, showing you a linear workflow module in Rebase. So we have talked about a lot of things, what's going on in commit or merge or rebase. So we have a scenario that's going to be a lot more clearer while doing out on the lab. So we move on to our Linux machine and do the following works. So first we're gonna make a directory and move in the path. We initialize a local repo, create and edit the file and save it, add the changes to the staging area and commit it, create and enter a new branch called feature, create another file, edit, save, add it to the staging area and commit it. Move back to the master, have confirmation changes to the file, add it and commit it. Now merge the branch feature or the rebase branch feature. So this process is going to be same for the both, and in this section only we're going to have the changes, and we're going to check the commit logs on both the branches to see what the differences are. So this is the basic scenario. Now we move on to our Linux machine. So we have finished discussing about a brief scenario of Git Merge and Git Rebase. We are now in our Linux machine, and now we'll be seeing what exactly the log is being updated and what exactly happens when we do Git Merge and Git Rebase. So first, let me open up a terminal. So let's move out to that stuff, and then we make we call Git. So first we would today change it to like initialize a repo, and then we introduce a file. So this is you, the master is the main backbone of the software. Get a bigger workspace, and then we add it to the Git message. We create a new branch, and then we create a new file, feature.md, and we write this one to the staging area, commit it, the message new feature is. So the commit is done correctly. Again, move out to the master, and then we make some certain changes to our name, and right, and new feature is being tested in the master in software. We can write whatever we want here. Just text, save it to the staging area. Message message. New feature is tested. Okay, and ready to be implemented. So, okay, we have that list of files in master. It's main.md. So we can also check git log, and there we have committed only twice, and we can also see the difference between master and the feature. So you're going to see the new feature is being tested in the main software. This is not included in your features. So you can also check the difference as well. Feature and master. So the new feature is now released and ready to go. You have this missing. So it's the same thing one way around. Now we merge those two branches, Git Merge feature. So here I have used Emacs as the default text editor. So here I'm going to write a message. Okay, new feature was is commanded to be software. So now we save it. Okay, so log. In the master, if you check the git log, we have 1, 2, 3, 4 log messages. And this is the main commit which we did in the first, and then this is the new feature is up. This is the commit we did in the feature branch, and then the new feature is tested okay and ready to be implemented. Is we came back to master, and then we commit this message, and we have this additional extra merge branch feature. The new feature was quite helpful and is commanded to be included in the main software. This was what we wrote it in the Emacs text editor. So every time you git merge, you need an extra commit history. You add an extra commit history, and that's in this case is shown by this log. So this commit message is going to be an extra if you do it by using git merge. But if you do it by Git Rebase, you'll only be getting 3 commit messages. So let's check out on Git Rebase. Okay, now we start with Git Rebase. Okay, we get me a terminal here. We move on to desktop, and we create a new directory called Rebase. To that. And first we're gonna initialize a repository get init. So initialized empty git repository, that's good. Now we're going to create the text.empty. So let's be main comment. So check out another branch called feature, and we create a new file feature.md. So it's released and to go. Let's this one. Okay. Yes. So, okay, let me maximize my line. So we add it to the staging area and commit it. This is free. So it's committed, and then we move back to the master, and then we make some changes to the file. So let's see what we have. This is the main backend of the software, and new feature is built will be implemented. It's okay. So it staging here. It the coordinates is the new feature is tested okay and command be implemented. So okay, commit has been done. So now we do the rebase git rebase feature. So what it does is basically it first rewinding head to replay your work on top of it. So as I've already shown you on the diagrammatic representation of Git Merge and Git Rebase, like how it basically works from jumping of nodes and branching out. So what it does is at the while doing Git Rebase, it basically goes back to the top of the branch, not the tip, but the top of the branch. It runs back to the top of the branch. It executes the steps on that branch at the tip of the master, what you are standing at, and then it replays everything. So basically, if you have a bug, let's say if you have done like 4 or 5 changes in your feature branch, and you have some problems, you have some bugs in your third step, and while you do Git Rebase, it rewinds and get replayed from the step 1, and then going back, and then you have the bug on the third step, then it is quite easier to get bisect and find out that your bug was in step 3. While in case of master, it's just like the tip of the branching node gets merged to the master, so it doesn't quite get you the enough info about the previous branches and what you did and everything. While doing git bisect, it is pretty much hard to find out where the error came from and everything. So at first, rewinding head to replay your work on top of it, applying the new feature is tested okay and commanded to be implemented. That was my commit message. Now we can like check the log. So here we have only 3 commit messages, as I've already told you before while doing Git Merge. So the main commit, the new feature is ready, and the new feature is tested okay and commanded to be implemented, and we do not have that extra merging extra commit message while doing a merge. So okay, that's all for today, everybody. Thanks.